Ha! So our goal here is to get the derivative of f of g of x, a compound function. And as an example, I'd like to consider the square root of 2x plus 1 as an example of a compound function. And we're going to break this up into inside and outside. And the outside function is going to be the outermost layer, and the inside function is going to be everything else. If I think about this, even about the way I speak it, I pronounce it as the square root of 2x plus 1. So I naturally have an outside function, which is the square root of u, if you'll let me use that variable.
Why u?
Could be w, could be any variable here. So let u equal. And I have an inside function, which is 2x plus 1. And when I put those two together, then f of g of x is found by substituting the 2x plus 1 in for u, and that gives me root 2x plus 1. Does everybody see how I'm taking this apart? Taking it apart and putting it back together.
So I'm guessing you can do this for square roots too.
Oh yeah, you can do it for anything, right?
Like u squared.
Right. Exactly. So I'm going to identify the f as the outside function, and I'm going to identify the g as the inside function. Some people like to use u's. Some people like to use just open parentheses to indicate that it's sort of an outside form. So I could have also written this as f of whatever is the square root of whatever. Sometimes you'll see that. You like that? Yeah, that helps students visualize it sometimes, because the u distracts them sometimes. Same thing with this. If I have a function 3x minus 3 minus x to the 5th power, then I can think of this as an outside function, and my outside function would be whatever to the 5th power, or splat is the official mathematical term, splat to the 5th. I'm joking, by the way. Cool, anyways. And the inside function is going to be whatever's on the inside, which is 3 minus x. And so when I put those two together, f of g of x is equal to 3 minus x to the 5th power. Ta-da. So I took it apart and I put it back together. We can do this with all sorts of stuff. Identify outside and inside for me. Go. Just wait. Right now I'm just helping you visualize. And then we're going to have a theorem. And what is my outside, Luke? Outside is cosine, and the inside, you?
X squared.
X squared. Just like that. Outside and inside. Now, this was pretty easy to visualize. There is one set of functions that is slightly tricky to visualize because of the way it's written. And I want to be clear about that right now. Everybody see this guy right here? Because of, for historical reasons, really because of typesetting reasons, this is written like this, but when you see that, everybody has to understand that this means the cosine of x squared. It doesn't mean x to get squared. It means that you take the cosine of x and you square, right? You remember that? That means that for this one, my outside function is going to be the square function. The inside is going to be cosine of x. And when I put those two together, then f of g of x is spelled cosine squared x. So that's just a spelling thing. Does that make sense to everybody?
Why don't they just use cosine x squared?
In computers, they will. If you type in cosine squared x into MATLAB, you type it in as cosine of x squared. Yeah. It's really because until very recently, it was actually hard to typeset math really well because you've got three different layers, right? You've got your text, you've got your subscript layer, and you've got your superscript layer, right? And so it's actually expensive to go through and typeset all that stuff. So if I needed extra parentheses and blah, 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 then I would have to have two different pairs of parentheses, one for the x and one for the outside, and then I'd have to put the superscript in a layer even above those three layers because the outside. So it was just expensive to do it. Nowadays, with computerized typesetting, that's not a problem.
Money is always the reason.
Money is the reason, that's right. You got it. Time and money. Is everybody clear on how outside and inside works? Now Joseph's question is the $64,000 question. How does this help us? It's going to be very straightforward. Today I'm going to give you a theorem. Tomorrow I'll prove it for you. And here it is, the chain rule. The derivative of a composite function is equal to the derivative of the outside times the derivative of the inside. That's it. The derivative of the outside times the derivative of the inside. And if I write it in Leibniz form, it's even nicer. Watch this. If I call that inside function u, so that I'm taking the derivative with respect to x, one variable, of a function of u, a different variable, then my result is df du, the derivative of the outside, f prime of u, times du dx, the derivative of the inside. Wow. First of all, let's see how these are equivalent right here. Here, I'm talking about f prime of g. In other words, I'm talking about the derivative of f with respect to g itself, which is u, times g prime of x, which is du dx. But the reason this is really nice to write like this is that when I write it like this, what does it look like that you remember from physics or chemistry? It looks like conversion factors. And that's exactly what it is. Multiplying by du dx converts a derivative with respect to u into a derivative with respect to x.
So really it ends up equaling df dx.
It does. But I was able to expand it in such a way so it's like multiplying by 1. Now let's see how this works, and you'll see both of these in operation. Okay? Now, visually, outside, inside. What's the outside function? 3 minus x. To the fifth. Yeah, it's the one we had before on the previous page. Outside, inside. So the outside is whatever to the fifth. If we think about it in terms of u, it's u to the fifth. That's my outside. And the inside function is 3 minus x. And so now we're going to consider derivative of the outside times the derivative of the inside. The outside form is splat to the fifth, and so its derivative is splat to the fourth power. Don't touch that inside. Times the derivative of the inside function, which is 3 minus x. And the derivative of 3 minus x is easy. It's negative 1. I can clean all that up. All right, so explain your confusion.
I mean, oh, I do understand it, but couldn't you just keep taking the derivatives until you get a big number, just like 3 minus x, and then solve it like that? Like the derivative of 5 times 3 minus x to the 4th, wouldn't that be, or I don't think I'm thinking right.
Are you thinking, could we just do algebra to this and expand it?
No, I mean like, just keep taking the derivative of it until we get to one number in front of 3 minus x.
I could, but then I'd have like the 5th derivative, and I'm interested in only the 1st derivative.
Oh, it would, yeah, I guess like, never mind, that
Yeah.
would be different, never mind.
That would be different. Okay, good. Let's come back and look at this exact same problem again, but we're going to look at it from the point of view of the Leibniz notation with our FOV. Yeah.
This is a little confusing how you jump from you jump from the derivative of 3 minus x to the 5th, and then it went 5, 3 minus x to the 4th. I'm not trying to, I want to see where in the equation that we went over here, where it shows that.
Ah, good. Okay. So coming back to here, my f of g of x was 3 minus x to the 5th power. And so from my form, first I'm going to find f prime. What was my f? My f was splat to the 5th. So its derivative would be 5 splat to the 4th.
That time.
I'm just looking at this part right here for now. So this part is my f prime of splat.
Okay.
Does that make sense? And then times g prime of x, which is here, the derivative of the inside, which is negative 1.
Okay.
Does that help? Good. So if I were to come back and I were to do it with substituting u for 3 minus x like this, then it would look like this. The derivative with respect to x of u to the 5th should be equal to the derivative with respect to u of u to the 5th times du dx. There's our conversion factor concept. And the derivative with respect to u of u to the 5th is 5u to the 4th times du dx. And 5u to the 4th is the same as, what is u? 3 minus x times the derivative of u, which is negative 1. And so I get the exact same answer by visualizing it in a slightly different way. Just like that. But our slogan is really what carries us. We're going to think of it as derivative of the outside times derivative of the inside. And that makes it fairly simple.
Why though?
That you have to wait for the proof, and that's wrong.
Oh.
It's not a problem.
Come on, Peter, he's gotta make this really, he's gotta give us a cliffhanger,
Actually, no, I've got to give you practice. Okay? So, before you begin, identify outside, inside. What's the outside function? Cosine. What is the inside function? X squared. So I'm going to think of this as the derivative of the outside. The derivative of cosine is negative sine of whatever is on the inside. It's the derivative of just the outside, don't touch that inside, times the derivative of the inside. Now, I know that you could probably have done that derivative of the inside in your head, but I'm going to ask you to, for tonight and tomorrow night, to explicitly write times the derivative of the inside, just like I did right here, so that the chain rule is firmly implanted in your brain. And I have a reason for it, because we're going to end up with multiple chains in the future, and if you don't think about it like this, if you're not visualizing it properly, you're going to get it all wrong. Now that we've done that, what is the derivative with respect to x of x squared? 2x. And if your inner nerd feels compelled to clean it up, then you would write it just like that.
how did you get negative sine squared?
I didn't. I got negative sine of whatever was on the inside. So the derivative of the outside function was negative sine.
So u was equal to cosine
Nope,
x.
u is equal to x squared. U is the inside function. Yeah. So we would think about this as cosine of u, and that should be equal to negative sine of u times du dx. That would be the way that Leibniz would write that. So the derivative with respect to x of cosine u would be negative sine u times du dx. And there's our cumulative. Let's do another one.
What was the outside for that?
Cosine.
So the derivative of the outside would be negative sine
Uh-huh.
times.
Times the derivative of the inside.
Yeah, but if the derivative of outside was negative sine, where did the x squared come from?
Well, it's the cosine of what? It's the cosine of x squared. So the derivative should be negative sine of x squared times the derivative of the inside function.
Okay.
Yeah, cosine, this is not pronounced cosine times x squared. This is cosine of x squared.
Oh.
I'm substituting x squared into the cosine function, right? All right, outside, inside. What's the outside function? What's the inside function?
3x minus 1.
All right, now, focus just down here if you're having trouble visualizing this. Just on the outside, what is the derivative of my outside function? Root splat. Does everybody agree that the derivative of root splat should be 1 over 2 root splat? Okay. And what is the derivative of the inside function? 3. Easy. And these are the two parts now that we put together as our factors. The derivative is going to be 1 over 2 root splat times the derivative of splat, outside, inside, which is 1 over 2 root 3x minus 1 times 3. And I can clean that up if I want in a lot of different ways, but the usual way would be like this. How many of you think you got it? I see MS nodding your head back there. You got it. Heidi's got it. Who else?
The function f is outside.
The function f is the outside function. That's right.
Let us do one.
Exactly. Go. Identify the outside and the inside. Figure out the derivative of the outside and the inside. Multiply the derivative of the outside and the inside. Okay. What was your outside function? What was the outside?
Cosine x squared. Oh,
Squared. And what's the inside function?
Cosine x.
Cosine x. All right. So the derivative of the outside function is 2 cosine x times the derivative of the inside, which gives you 2 cosine x times negative sine x. And probably you would see it written like this, but if you were spiffy with your angle, double angle identity, you might even see it written like this, but probably like that. Okay.